Hi friends, in this video we'll see how to develop a simple linear regression model for a real-time data set. So generally when you collect your data, it will be available either in the Excel format or in the CSV file. So that you have to use this as an input, and using the Python programming you need to develop the simple regression model. And this is the data set I'm going to use. I have kept this data set in the Google Colab, and here my data set containing the diabetes information, and I have the various fields like age, sex, the BMI, then blood pressure, then serum level, then LDL, cholesterol, HDL, and the total cholesterol level, LTG, and the glucose level, and the last one is the predicted value, that is the diabetic progression level. And this only we are going to use as our target, and remaining all the inputs generally it will be accessed as a input, that is your independent variable, and the last column is our target, that is our output or the response, or you can call it is a dependent variable. So since here we are going to use with simple linear regression, I am going to consider only the blood pressure as the input, that is my independent variable. How the blood pressure is going to impact on the diabetic progression level. So for that I am going to develop a simple linear regression model. So I am going with the Google Colab notebook, and here I have imported some basic libraries. The first library which will support the data frame, and I have my data set in the Google Drive, so that it need to be imported. So I have a library google.colab, from that importing the drive, and this I have to run first. Next I need to import my Google Colab drive, and followed by my file is available in my Colab notebook, my drive, and the file name is diabetes.csv. So this will ask me for the authentication. So I am permitting to connect with my Google Drive, allowing it to access my Google Drive. So once it is ready, once the drive is mounted, you are ready to access the CSV file available inside your drive. So it will take some minutes to mount it. Yes, now it's mounted. So now the next step, I need to load my data set. So by using read_CSV, you have read the file. So since you know about this index._column, so if I remove it and execute, I will get one extra index column. So in order to avoid that only, we have this index_column is equal to 0. So since you know you have 10 input columns and 1 predicted column, and since we are going to use with the simple linear regression model, I am going to consider only the blood pressure as my independent variable, and the progression level is my dependent variable. So from the input data set, I need to prepare my inputs. That is, my input is BP and my output is the progression level. So to create my input data set, I am using with X. From the data frame, I need to take only the column of the BP. So I need to analyze how the blood pressure impact on the diabetic progression level. So Y is equal to DF. My output is the progression level. So my input and the output is ready. My input vector and the response vector is ready. And here I am having almost, so you need to know what is the size of it. So I need to give print x dot shape. So totally I have some 442 elements or the observations. So from this entire data set, some part I need to use for training my model, so that my model get developed and I will get my slope and the intercept, that is my regression coefficient, which is suited for my linear regression model. So once my model is built, next by using the model, the remaining data will be act as a testing data, and I need to analyze the performance of my regression model. So the input data 442, I'm going to divide into training and the testing. Since you know machine learning having two phases, training phase and the testing phase. So out of my 442 data, I am going to use 60% of data for my training, 40% of my data for testing. It can be 50-50, 75-25, okay, so or 60-40. So here I am adapting with 60-40. So in order to do that, first I need to import one library. So I have to use with from Scikit Learn dot model selection import train test split. Okay, so from the 442 data, using this library itself, you can divide your data into 60 and 40. 60 for training, 40 for testing. So I'm going to develop my training. That is my testing data. That is the input X. I'm dividing into training testing. Same thing, the Y I need to divide into training and testing. And this will be done by a function called as train underscore test underscore split. You pass your X value, you pass your Y value, and then what is the size of your test. So it means 40% I'm using for testing, 60% using for training. So that will be taken with random. So random state I am initializing with 1. So now my data are ready. So I can able to display and check how much training data I took, how much testing data I took. So print X underscore train dot shape. And print X underscore test dot shape. So it will, out of 442, you have 265 data, 60% of data for training and remaining 40% is used for testing purpose. Now our data are ready. The next step, we need to create our linear regression model. So in the Scikit library itself, all the machine learning algorithm built-in libraries are there, and from that you need to initialize the linear regression model. First you need to import the library. So from Scikit Learn dot linear underscore model import linear regression. So now the library imported, we need to create one variable that you need to initialize the model. So the model get ready. The next step is we need to train the model. So generally, in order to train the model, we have a function called as fit. This model requires the input in a two-dimensional array, but our input is available in a one-dimensional array. So we need to reshape our data that should be converted as a two-dimensional array so that it will be given as an input to the fit function. So in order to do that, first you need to do the data conversion. That is your X train data. In the NP, you have a function called as NP array. There you need to pass the training data and reshape the data to two-dimensional array. So to initialize, you need to import numpy as NP. The same way, our Y-train data also need to be converted as a two-dimensional data. So using Y-train, you have reshaped it. So now the data are ready in a two-dimensional. It should be passed to your fit function. X train and Y train. So now the training get finished. Yes, so the training is ready. The model get trained. So we need to display what is our intercept value and the slope value of the model fitted with the training data. So print model dot coefficient and then print model dot intercept. So at the end of the training, the linear regression line y is equal to b0 plus b1x based on the training of x input data and the y predicted data. Our model get fitted with the b0 value and the b1 value. Intercept and the coefficient is ready. So now our linear regression model is ready. Next, it need to be tested with the testing data. So I have written specifically here, but I have did everything here. The linear regression model I have created. So actually I need to train the model and then I need to print the result. Regression coefficients. So training data set is ready. Next, the model is trained with the fit function and the regression coefficients are displayed. The next step, using the testing data, you need to predict how much the model can able to give a prediction with the new data. Okay, because it is trained with the label data with the input and the output. Now we are going to give only the input data so that our model can able to predict the output target. That is the diabetic progression level it needs to predict. So in order to do the prediction function, the model where you have a function called as predict, you need to pass your test data. Only the input data we need to pass. So it will find out what is the corresponding predicted label for the testing. So now our model is working with the predicted data. Again, the data you need to convert with the two-dimensional array. So we need to prepare our data. X test is equal to np dot array x test dot reshape minus 1 comma 1. So now testing is over. Now we have the original y value for the x test and now you have the predicted data for the same x test. Okay, so for the testing input we have the original y value and also we have a predicted y value. So now we need to find out the difference, that is the error. So error represents the original value, you have it in the y test and the predicted value. So we print it, print the error. So again it having a format, one-dimensional, two-dimensional format exception. So again I need to convert my y test also to the same format of 2 dimension. Y test dot reshape minus 1 comma 1. Yes, so now my error difference will be that between all my testing inputs, the original value and the predicted value, the difference is given. So based on this error only, we need to calculate our performance metrics. So before calculating the performance metrics, we just display the line of regression along with what you get for your output. And for that, first you need to import matplotlib.pyplot as plt. So we are going to display our distribution of data for the x test with the corresponding y test. The dots we are going to scatter it, and whatever you got from your regression line, okay, whatever you got from the prediction, and that we are going to display as a line plot. So we are going to execute it. Yes, so actually you see here your original data are scattered like this. For the real test data, the data are scattered in a blue color. But when you predict it, the value are fitting in a linear line. So in order to fit it properly, instead of displaying the scatter plot, I will use with the line plot. Sorry, I will use with plot. Okay. Yes, so it will be fitting like a line. Actually, this is the error. The point is the predicted value, whatever you get for the model is in the red color line. But the actual value is this blue color. The difference between these two represent error. Okay, so our model having some error based on the predicted value and the actual value. So that only evaluate the performance of your linear regression model. And to evaluate the performance also, we have various measures: mean absolute error, mean squared error, R-square error, and the root mean square error. So to work with that, information is also available in your Scikit library itself. So you need to import it from sklearn.metrics import mean absolute error, then mean squared error, and the next one is R square error. That is the R square score. Now we'll execute it. We need a math function because we need to apply a root mean square. So we need a math function. So import math. Yes. So now we have our performance metrics: the mean absolute error, mean squared error, the variance score, and the root mean square error. So generally the error should be less. So what you can do to reduce the error? Maybe this blood pressure is having only a less impact with your progression level of the diabetics. The other fields, maybe the cholesterol level, that may have or the glucose level may have a high influence with the progression level. So we need to analyze with our independent variable which input variable have a high impact on your output variable. So from this analysis, you can able to see the blood pressure is not having a more impact on the progression level of the diabetics. So now we have used only a single linear regression model. So in order to improve your regression model, you can go with the multiple linear regression model. So that time, instead of considering only the blood pressure, you can consider multiple input variables. That is the BP, cholesterol level, then your glucose level, your BMI level. So how each and every one impacting your output variable, you can consider with multiple linear regression model. So that time you may get an improvement in your linear regression model. But here we are considering only one data as an input variable. Based on that, you are finding what is the impact on your target variable. So that you are analyzing with your performance metrics. So further, you can update your linear regression model with different inputs, or by using the multiple regression variables or multiple input variables, you can analyze the performance of your linear regression model. Thank you.